All right, the TPs we should have discussed on Friday, but did not have time in class. Here we go. Number 17, log base 3 of x is -1. Let us remember my famous sentence, a logarithm is an exponent. Log is exponent. Here's my exponent on that base. So x is 3 to the -1, or x is 1/3. 17b, log base 2 of x is -4. Log is exponent. There's my exponent on the base of 2. So x is 1/16. All right, now we're going to solve for x. Number 21. Number 21, solving for x. 3 to the 2x is 75. What wonderful feature do we have is logarithm functions, which allow us to bring that exponent down. So we are going to take the log of both sides, so I can bring the exponent down, and I can solve for x. Divide by natural log of 3, which, by the way, this is not natural log of 75 over 3. That would be very wrong. Okay? And dividing by 2. You want to get your problem like this completely, so that then when you enter in the calculator, it's a one-stop shop. You do one calculation, and you should get that. Now, what I do not like about the textbook is it rounds every answer and gives it to you that way. What you need to understand about this, for me and especially for AP, all of your calculator answers must be correct to 3 places past the decimal. You can either truncate, which means stop after 3, or you can round up. But if you round wrong, you will not earn the credit for that point. So I would caution you to be careful. I think it is best to write several decimals down, and they stop reading after 3. If it is correct to 3 places, you're good. 39. We need to take the derivative, and it's going to require product rule. Again, we're dealing with t in this problem. Put little hooks on your t's so you don't think they're plus signs. All right, so the derivative is t squared times the derivative of 2 to the t. Let us remember, the derivative of an exponential function is the exponential function times the natural log of the base. If that exponent is a u, it is still the exponential function times the derivative of the exponent times the natural log of the base. Okay? Now you may be saying, well, how come when we took the derivative of e to the x, we didn't do that? Well, we technically did. It is the exponential function times the natural log of the base. Oh, what's ln e? That is 1. So we actually did do it. I just didn't really tell you the whole truth back with that one. All right, so here we go with our product rule. G prime of t is t squared times the derivative of 2 to the t, which is the exponential function times the natural log of the base, plus 2 to the t times the derivative of t squared, which is 2t, which is why you can't call this here 2t that some of you do. This is not 2t, it is 2 to the t, this is 2t. And I can clean it up ever so slightly. Each of these terms has a 2 to the t, and each of these terms has a t. So factoring out the common factor gives you that beautiful answer. You could also write it like this, switch the order of that, it doesn't matter. 43, now this one is interesting. We want to simplify it first before finding f prime. First simplification is looking at our log of a over b gives us log a minus log b. Also, something important to pay attention to is this must be positive and this must be positive. So x squared must be positive, meaning x must be positive, and x minus 1 must be positive. So x has to be greater than 1 because I need to look at the overlap of these two solutions. So if I were going to do something, what I have is this is my domain. My domain is this is true for all x's greater than 1. All right, now I'm going to look at this. I can bring that exponent down, gives me this. And I don't like working in log base 2, although you could memorize the formula for the derivative of log base 2. But why don't we use our change of base formula? Log base a of b is ln b over ln a. So I'm going to change log base 2 of x to ln x over ln 2. And log base 2 of x minus 1 is ln absolute x minus 1 over ln 2. You know I don't need that absolute if I have stipulated that my domain is greater than 1. Now, notice that I still haven't taken derivative. What I can see is that I can factor out the 1 over ln 2. That leaves 2 ln x minus natural log of x minus 1. That must be in parentheses. I still have not taken derivative, but now I am ready to do it. This is my coefficient. 2 times derivative of ln x is 1 over x, minus derivative of ln u is u prime over u. So that is your derivative. We could do a little work here getting our common denominator, this product minus this product over this product. Doing the algebra on top, that's 2x minus 2 minus x, which gives us, x minus 2 on top, over natural log of 2 times x minus 1. Maybe a better way to write this is x minus 2 on top and x times ln 2 times x minus 1. I don't know. All right, 5 to the negative x. We're going to integrate this. Our u is negative x. Our du is negative dx. If we are in the form a to the u du, we know this will integrate to 1 over ln a to the u plus c. You've got to learn those patterns. So let's get our integral fixed correctly. We need the negative dx, multiply, divide by negative, and now this will integrate to 1 over ln 5 times 5 to the negative x times that negative 1 that's there plus c. If you want to, you could write this as negative 5 to the negative x over natural log of 5 plus c. All right, 68, we have a definite integral. Let's notice our base is 4. Our u is x over 2. Our du would be 1/2 dx. And I want to get the integrand in the form of a to the u du so that this will integrate to 1 over ln a times a to the u plus c. All right, so first things first. My du is 1/2, so I need 1/2 dx. That's going to get compensated for by the 2 on the outside. All right, so notice I have a to the u du. That will integrate to 1 over ln a to the u, no plus c because it's a definite integral. Also, I didn't change my limits of integration because this one's not that hard. So I have 2 a to the u, 1 over ln a from negative 2 to 2. Now I'm going to bring that ln 4 out and deal with that at the end, okay? So we have 4 to the x over 2 from negative 2 to 2. Substitute the 2 in. Substitute the negative 2 in. Notice that ln 4 could be written as ln of 2 squared, where the 2 would come down. So this right here simplifies to that, which is nice because I can cancel those 2's. Remember, this is still in the denominator. Now, 4 to the 2 over 2 minus 4 to the negative 2 over 2 gives me 4 to the 1 minus 4 to the negative 1. Let's clean that up a little bit. 4 minus 1/4, which is 15/4. So 1 over ln 2 times 15/4 becomes 15 over 4 ln 2. That's just that way we write it. Looks a little bit better. And finally, number 90, let P equal $100. And our time is from 0 to 20. So at 3%, our equation is A equals 100 e to the 0.03t. At 20, we have this amount. For 5%, our equation becomes A equals 100 e to the 0.05t. For 20 years, gives us this. At 6%, again, we get about $332.01. And here are what the graphs should have looked like when you went to graph them. And this concludes section 5.5 TPs.